So a perpendicular bisector is perpendicular to a segment at its midpoint. When we talk about point of concurrency, I'll write it on the board if I had markers. Get your lines together. All right, here we go. Can anybody tell me what concurrent means? We learned it in the last section, so if you don't know what it is, it's in the last section. Concurrent.
Point of intersection of the lines, rays, or segment.
Okay, so when how many lines, rays, or segments intersect?
3.
You read the second, yeah. So when 3 or more lines, rays, or segments intersect. So, what kind of lines are intersecting when I'm asking you the point of concurrency?
Perpendicular.
Where the perpendicular bisectors intersect, they form a center of sorts. Does anybody remember what the center is called?
Center.
Circumcenter. And the property is that distance is equal distance to the vertices. And vertices is the same thing as the angles. All right, this is the harder question. What does an angle bisector do?
Something that cuts an angle in half.
Cuts an angle in half. Guess what the definition is? Bisects angles. But I liked yours too. The point of concurrency where angle bisectors intersect is an incenter. It's an incenter. Third time I've heard it today. All right, and then with an incenter, the distance is equal to what? It's not the angles. It's the sides. Equal distance from the sides. So we're going to talk about medians and altitudes. I will tell you right now, Eric Foraker, medians are extremely important in this section. When I looked at your test review, it had a significant amount of medians and a significant amount of their point of concurrency. So we're going to talk about it today. So I'm telling you right now, this column is extremely important. Altitudes, we're going to learn the word. We're going to learn the center. There's no math to it. So altitudes are not as important as medians are. Okay, I'm telling you right now. Hopefully you took note of that. So we're going to talk about medians to begin with. This is what we're learning today. To use medians to find centroids, what is the root word of centroid? Center. What's the root word of orthocenter? Center. So, we're learning 2 types of centers. A median of a triangle is a segment from a vertex to the midpoint of the opposite side. This is not going in the chart. It is going in the center of your notes page. You do need a highlighter. You'll highlight what I have highlighted. So a median of a triangle is a segment from a vertex to the midpoint of the opposite side. You'll highlight what I have highlighted because this is a median. Because angle A is my vertex. This point down here is my midpoint. So I would highlight my median. All right, so you have not learned this yet, but if you look directly under this picture of a triangle, it says point of concurrency for medians. It's called a centroid. C-E-N-T-R-O-I-D. Point of concurrency for medians is called a centroid. C-E-N-T-R-O-I-D. And we're actually going to make them. So you see, you have these pictures on the bottom. What kind of triangle do I have in my first triangle? Acute, right, or obtuse? Acute. What kind of triangle in my second?
Obtuse.
And what kind of triangle in my third? Right. So we're going to figure out where the centroid is in all of these triangles. A centroid is from the midpoint to the opposite vertex. So guess what the first thing we need?
Midpoint.
A midpoint. So go ahead and find the midpoint of each line. Oops, go backwards. Go ahead and find the midpoint of each line. You can use the ruler, but please don't take 5 ever. 5 ever is longer than 4 ever.
Like 4 head or 5 head?
Yeah, but 5 head is accurate. So be as quick, but as accurate as you can be. We are now going to draw from a midpoint to the opposite vertex. What vertex is opposite of this midpoint that I've circled? A. So I'm going to draw a line from that midpoint to letter A. Sorry, I didn't mean to pick this random one. I will do that for all of them. Midpoint to the opposite side, midpoint to the opposite side. So midpoint, opposite side, midpoint to the opposite side, midpoint to the opposite side. You should have a center where they all intersect. This center will be called a centroid. The three medians of a triangle are concurrent. Their point of concurrency is called a centroid, which you just did. Your fill in the blank is that a centroid is always inside of the triangle. All right, so a centroid is always inside the triangle. What other center was also always inside the triangle?
In-center.
An in-center. What's an easy way to remember that the in-center was also always inside? In and in. Okay? We will do an activity over this tomorrow, and you will need to know that these two are always inside. There is a special relationship formed by a centroid, and it is not an equal, and it's not half, or anything like that. Would you agree that centroid is kind of a weird word?
Yeah.
I would think it's a weird word. So here is what I tell people. Centroid is a weird word. It has a weird property. When you learn it, it is very simple. As long as you stay with me, I show you the shortcut way of doing it instead of doing it the fraction way. You can pick whatever you would like to do, but I show you. So the relationship, which you have a blank for, here's my centroid. The centroid of a triangle is 2/3 of the distance, so your blank is 2/3 of the distance from each vertex to the midpoint of the opposite side. So 2/3 is your blank. All right, so I will show you. If P is a centroid, then if we see AP is equal to 2/3 of AD, meaning, so we have this whole line which is highlighted in orange. Okay, from the vertex of the angle to the centroid is going to be 2/3 of the line. So then how much is PD going to be?
2/3.
AP is 2/3 of the line, so what's remaining for PD to be?
Another 2/3.
1/3.
Oh.
1/3 of the line.
Okay.
Calm down. It's okay. All right, the same thing. From the vertex of your angle B to P will be 2/3 of the entire line. So if BP is 2/3, okay, it obviously looks longer than the other piece. PF will be the 1/3. And I know you guys are looking at this like, oh, 2/3, 1/3 doesn't sound like fun. It's actually very simple, and I will show you. You're going to flip to the next page, and you're actually going to draw a line. Just draw a line. It does not have to measure anything in specific. Please don't be... Just draw a line. That's all I'm asking. Draw a line, and it will be 12 long. 12 units long, whatever. So the whole line is equal to 12. All right, so then you'll put a dot just like I have. All right, so is this piece the 1/3 or the 2/3? This would be the 1/3 just because you can eye it. So that means the other piece would be 2/3. So here is what you need to understand. Do any of you ever bake? Okay. So if you bake and the recipe calls for 2/3 cup of sugar, some people do, but normally do you have a 2/3 cup?
Yes, I do.
Okay, congratulations.
What do you do if you don't have a 2/3 cup?
Eyeball it. You do 2
No, you cannot eyeball in baking.
1/3 cups.
You do 2 1/3 cups. Because 2/3, focus. So 1/3, if you doubled it, so times 2, equals 2/3. We agree? 1/3 times 2 is 2/3. If you bake, you know, if you needed 2/3 of something, you would take your 1/3 cup and you would just dip it twice. It's going to be the same thing. So here's what I tell people to do. Let's find 1/3 of 12. So you can divide 12 by 3. What is 12 divided by 3? 4. So this piece of the line is 4. Because 2/3 is double of 1/3, guess what we can do to the number 4?
Multiply by 2.
Multiply it by 2. We can double it. So that means the other piece will be 8. Because we found 1/3 of 12, which is 4. 1/3 times 2 is 2/3. So 4 times 2 is 8. What is 4 plus 8? 12. Okay, so we found that. You could also just multiply 1/3 times 12. You could also multiply, which is 4, 2/3 times 12, which is also 8. Centroid problems, this is more so what you'd be seeing. Point Q is a centroid, and VQ is 5. So does VQ look like the 1/3, 2/3, or the whole line?
1/3.
It looks like the 1/3. So we can do a couple of things. We know that VQ is 1/3, which makes QR the 2/3. So what can I do to find QR? Multiply it times 2. What's 5 times 2? 10. So QR is 10, which would make the whole line of RV equal to 15. Here was the other option that you could have done. Since 5 is the 1/3, to find the whole line, you could multiply it times 3, which is 15. And then you could subtract to find 10. There are a lot of things that you can do. I personally double and then add. Any questions on how we found 10 and 15? Yes, ma'am. Okay. All right, our last one. Point P is a centroid of triangle LMN. So we're given QR. So I'm going to draw. QR is 12.6. Find PN and QP. So I tell you, when you're given the whole line, what is the easiest part to find? The 1/3. So let's find the 1/3. What would be the 1/3 in this picture? QP. Well, we're getting there. So if I want to find the 1/3, I need to divide the whole line, which would be 12.6. And I need to divide it by what number? 3. What's 12 divided by 3? 4. And what's 6 divided by 3?
2.
So that means QP is 4.2. So if my 1/3 is 4.2, how do I find my 2/3?
Multiply 2.
Multiply it by 2. So then I get PN is 8.4. And what should these add up to? 12.6. And they do. 4 plus 8 is 12. 2 plus 4 is 6. Go ahead and flip. We have one last thing to talk about.
How do you know to divide by 3?
Because I'm finding the 1/3. It's a good question. If I multiplied 1/3 times 12.6, I would end up with 1 times 12.6, which is 12.6. 3 times 1 is 3. So it's the same thing as dividing by 3. All right, the last one, we're just learning this word. An altitude of a triangle is the perpendicular segment from a vertex to the opposite side. So an altitude of a triangle is the perpendicular segment from a vertex to the opposite side, or the line that contains the opposite side. Every triangle has 3 altitudes. The lines containing the altitudes are concurrent and intersect at a point called the orthocenter. An altitude can lie inside, on, or outside the triangle. What other kind of center can be inside, on, or outside? Circumcenter. So a circumcenter can also. They are inside when you have an acute triangle. They're on the triangle when it's a right triangle. So think of right on. Is that too old of a saying? Y'all have heard of right on?
Yeah.
Like, right on. Nope, it's right. And then obtuse would be outside of the triangle. All right, so a median. In layman's terms, where does a median go from? What do we call the middle of the line? The midpoint. So it goes from the midpoint to the vertex. Yeah. So it's a segment from the vertex to a midpoint. The point of concurrency we talked about is a centroid. Yep. Centroid is 2/3 the distance from the vertex to the side. Here's an altitude. Its point of concurrency is an orthocenter. And there's no property. I used to have a quiz over this, but you guys have enough quizzes for the quarter. I might still give it to you as like a classwork assignment because you need more classwork grades.